Sketch the graph of a function not by plotting points, but by starting with the graph of a standard function and applying its transformations. So any transformation is going to look something like this. You have an a multiplied by some kind of function, and then we're going to have x minus h plus k. Now, we're not going to deal with the horizontal stretch because this one doesn't have one. But as you notice, this does not look like this. But if I take this 3 and I bring it over to the other side, I end up getting y equals negative 2 x minus 1 squared plus 3. Now it looks just like this, where h is 1, k is 3, and a is negative 2. Now if you notice, you have a function, and the function is what is happening to this x minus h, and that's getting squared. So my parent function is going to be just x squared, the simplest squared that you can get. Now, x squared looks like this. It's going to be 0, 0, and then over 1 up 1, because 1 squared is 1, over 2 up 4, because 2 squared is 4, and then it's going to be over 3 up 9, over 4 up 16, but we're not going to be able to fit it. So my parent function is going to look something like this. Now we're going to do the transformations on it. So first thing we're going to do is I'm going to take this vertex right here, and I'm going to move it where I need to go first. So we have x minus 1, as we realize it's x minus h, which pretty much means that x is always lying. We think it's going to go left, but it's actually going to go right. So we're going to go right 1, and that's going to take us here. So that's what that did. And then I'm going to go up 3, which is going to take us up to here. Now the interesting one is this next piece right here, this negative 2. So this pretty much says that every y value is going to change by negative 2. So instead of going over 1 up 1, I'm actually going to go over 1 and then down double that, so 2. So that's going to take us to here. And then I'm going to, instead of going over 2 up 4, I'm actually going to go over 2 and then 4 multiplied by negative 2, which is going to be down 8, which is going to be about right here. So I'm going to put that right there and that right there. So my new function is going to look like this. And if you notice, it does have a stretch of 2. It actually looks a little longer this way than the original graph did. And also we know that that negative is going to flip it. And if you notice, it kind of forced it to flip. So there you go.